What does it take to build an icon? Not just a big building, but a structure that instantly becomes a symbol of a city's ambition, a landmark that dominates the skyline with its sheer audacity. Look at Studio City Macau, a project of almost unimaginable scale and complexity. It features the world's highest figure-eight Ferris wheel, a facade of breathtakingly complex geometry, and all the functions of a fully integrated resort, all delivered under the immense pressure of a fast-track construction schedule. This isn't just architecture. This is a logistical and engineering moonshot. So how do the architects from Zaha Hadid's firm and the structural engineers actually pull this off? How do you design and build a figure-eight Ferris while that's suspended between two towers? And what role did advanced digital design play in making this impossible-looking structure a buildable reality? We're going behind the glitz and glamour to uncover the real architectural and construction secrets of one of the world's most fascinating megastructures. Let's start with the most iconic element, the golden reel, a figure-eight Ferris wheel. Calling it a Ferris wheel is almost an understatement. It's a hybrid structure, part ride, part architectural bridge, part sculptural art piece. Suspended in the void between the two hotel towers, it presents a monumental engineering challenge. The first question is, how is it supported? It doesn't have a central axle like a traditional wheel. Instead, the entire load is transferred to the two hotel towers through a massive, custom-designed space frame truss system. This truss had to be designed to handle not only the dead load of the wheel and its gondolas, but also dynamic wind loads, seismic activity, and the constantly shifting live loads as the gondolas move. A pro tip from structural engineers on such projects is the critical importance of wind tunnel testing. A structure of this shape and scale doesn't have code-prescribed wind load values. They must be determined through rigorous physical and computational fluid dynamics modeling to prevent dangerous vortex shedding and oscillations. The connection points where the truss meets the towers are among the most highly stressed elements in the entire building, requiring immense steel plates, high-strength bolts, and potentially even post-tensioning to ensure a perfectly rigid connection. Now let's talk about the overall form of the hotel towers themselves. This is where Zaha Hadid's signature parametric design language comes to life. The building isn't a simple rectangle. It's a sculptural form with a dramatic exoskeleton. This exoskeleton is not just for show. It's a key part of the structural system. By placing major structural elements on the outside of the building, you free up the interior floor plates from columns, allowing for maximum flexibility in hotel room layout and views. But this creates a massive coordination challenge. Every single panel of that exoskeleton, every connection point, is unique. This is where building information modeling, or BIM, moves from a helpful tool to an absolute necessity. The design team used software like Revit and Grasshopper to create a parametric model, where the geometry of the facade was directly linked to the structural model. A workflow secret here is using Grasshopper to automatically generate the thousands of unique drawings and fabrication files needed for the steel and cladding contractors. A common and catastrophic drafting mistake on a project like this would be to try and draw it in 2D. It would be uncoordinatable and filled with errors. The entire process is driven by the intelligent 3D model. The construction sequence for a project of this scale is a masterpiece of project management, often using software like Primavera P6 for critical path scheduling. You can't just build the towers and then hang the Ferris wheel. The sequence has to be meticulously planned. Likely, the towers were built to a certain height, and then the support trusses for the Ferris wheel were installed. This required incredibly precise surveying and temporary shoring. The components for the Ferris wheel itself were prefabricated off-site, shipped in sections, and assembled in place, a process resembling bridge construction more than traditional building. Meanwhile, the facade installation would be happening simultaneously, climbing the building as the structure rose. This is where clash detection in the BIM model is worth its weight in gold. Identifying a clash between a facade anchor and an internal MEP duct in the model before it happens on site saves millions in rework. The logistics of delivering thousands of unique facade panels to the correct location at the exact right time is a ballet of supply chain management that is as impressive as the engineering itself. Beyond the iconic elements, the building is a complex machine. It houses a casino, a theater, a water park, and countless restaurants. Each of these functions has its own stringent requirements for life safety, mechanical ventilation, and electrical capacity. The MEP, or mechanical, electrical, and plumbing engineering for this building, is a Herculean task. How do you get enough fresh air to a casino floor the size of a football field? How do you design the plumbing for hundreds of hotel bathrooms stacked in a non-rectilinear tower? The vertical shafts for these services had to be carefully planned within the core of the building, weaving through the complex structural system. A pro tip for MEP coordination in complex buildings is to use color-coded 3D models for each discipline: blue for plumbing, red for electrical, green for HVAC, and run automated clash detection weekly, if not daily, during the detail design phase. The goal is to have a zero clash model before issuing drawings for construction. In conclusion, Studio City Macau is a testament to what is possible when visionary architecture, cutting-edge engineering, and ruthless logistical efficiency converge. It demonstrates that today's architectural icons are born not just from sketches, but from algorithms, from sophisticated digital models, and from the flawless execution of a plan involving thousands of people. It pushes the boundaries of what we consider a building, blurring the lines between structure, machine, and art. As with all projects of this nature, it is crucial to remember the immense responsibility involved. The structural calculations, fire safety systems, and construction methodologies must be reviewed and approved by a multitude of licensed professionals and adhere to the strictest international standards. The information presented here is for educational purposes to illustrate advanced design and engineering principles. If you enjoyed this deep dive into the engineering and architecture of Studio City Macau and want to see us break down other megastructures like the Marina Bay Sands or the Burj Khalifa, please show your support by liking this video and subscribing to the channel. Let us know in the comments what you think is the most impressive aspect of this build.